All right, here we're going to look at another example of how to solve a system of equations. So the situation has changed a little bit, and the way we write the equations has also changed a little bit here. It says a large family is going out to dinner. The price for adults to eat is $13.50, but kids under 6 eat for $1. There are 18 people in total, and their final bill was $168. So the ultimate question here is how many kids and how many adults were there? So again, just like we do with a lot of other problems, we're going to define some variables. You could do like A and C here, but I'm going to use Desmos to solve this graphically here, and they really like it if you use X and Y, so we'll stick with those for now. Okay, but we're going to say let X equal the number of adults that are there, and Y be the number of children. If there's 18 people total, if I add together the number of adults and the number of children, that needs to equal 18, so there's my one equation here. The second equation that I can write, right, because this, right, there could be maybe 11 adults and 7 kids, or 10 adults and 8 kids, right, 15 and 3. There's a bunch of different ways to add up to 18, but if it was like, let's say 10 and 8, right, 10 times 13.50 would be, right, 135, plus 8 for the $1. Would only be 143, but we know that there was $168 in total for their bill, right? So this gives me one set of parameters to follow, but I need to find out, right? I need to create another equation to figure out how many exact kids and adults there were. So the second equation I can write is this, that, right, I know the total cost for the adults is however many adults there are, times it by 13.50, and that's how much the adults cost. And however many kids there were, times it by $1, and that's how much the kids cost. And if I add those two things together, I will get the total cost, and I know the total cost is $168. So again, I have my two equations, this and that I can solve graphically once again. Right? These are both in standard form. So if you wanted to graph this without the help of Desmos, you could find the y-intercepts and the x-intercepts, or I can just go to Desmos here, and we can just plug in those two equations. I have x plus y equals 18, right, is one equation, and the other equation is that 13.5 times x plus 1y equals $168, right? My window here is a little skewed. Let's go back to kind of the standard, that normal window. If I can figure out how to, home, there we go. And we'll zoom this out here and pinch some axes here to kind of help us out. If I click down here, I find out, right, there are, right, x is 12 and y is 6. Right, that's my solution to this system of equations here, right? So let's go back to here again. I'm just going to take a little screenshot of that so I can see, right? Here's my piece there. Oh, it went way over here. Right. There's my solution to this system, that x is 12 and y is 6, and we said that x was the number of adults and y is the number of children, so therefore I know, right, there were 12 adults and 6 children. Cool. So that's how to do it graphically, but again, we are going to work on the algebra, right? This is called algebra class, not graphing class. So this is a great way to do it. So when you have your equations, you can check and find out, like, this is the answer that I know I need to get to, right? I need to arrive at this answer where x is 12 and y is 6. But we are going to try to solve this algebraically. So again, I'll write out my two equations. We have x plus y equals 18. And 13.5x plus 1y is 168, right? The method we used last time was one called substitution, where I had like y equals something, and I could put that into the other equation, but I don't have that here yet, right? So I could use substitution again, but I need to do a little bit of work first, right? So what I'm going to try to do is to, like, this isn't in like y equals something, right? I need to get one of these two letters to be by themselves on one side of the equal sign. So let's get the y by itself in the first equation. I can spell. Right. So to do that, we have x plus y equals 18. If I want to get y by itself here, what I can do is I can like add a negative x or subtract an x from both sides of this equation, right? This becomes that zero pair that's going to go away. And so if if x plus y equals 18, then I know that y is 18 minus x, right? It's another way that I could write that. If they add together to make 18, when I subtract one from 18, I'll get the other. So now I have that, and then this second equation, the 13.5x plus y equals 168. And so now I have a y equals this, and there's a y in here, so I'm going to replace that y with what it's equal to, right? Y is 18 minus x. They are synonymous. They're the same thing. So where I see a y in this equation, I can replace it with the thing that y is equal to. It is equal to 18 minus x. So if I do that, then this equation becomes 13.5x. Let's go back to the blue here. It's 13.5x plus y is 18 minus x. I'm just replacing that, right? That y with what it's equal to, equals 168. And now I have one equation with the x, with only x, that I can solve just like I did in the normal, like, how do I solve an equation? So, right, I have this thing in parentheses. I don't really need them because I'm just adding both. So I have 13.5x plus 18 minus x equals 168. Let's put these two things together, right? Combine our like terms. I have 13.5 x's. I have another like negative x floating around, so 13.5 minus 1 gives me 12.5 x's. Plus 18 needs to stay, but again, these two are just coming together to make that 1 equals 168. I'm going to subtract 18 from both sides. The way Agile Mind has been showing this is like this, right, where I have this plus 18 equals 168, and I'm just going to, right, I'm going to subtract 18 from the left side and subtract 18 from the right side so that this becomes a zero pair and goes away. And I'm left with 12.5x equals 150. To get x by itself, the one last step is that we have to divide both sides by 12.5. To get x alone, x equals 150 divided by 12.5, or x equals, well, let's let Desmos check it out. That's 150 divided by 12.5. It is 12. The same x that we got there. Okay. So I know my x. Again, I need to find what the y value is. So just like we did in the first example, we need to find y by plugging in 12 into one of the original equations. 12 in for x. All right. So I have two different equations. Let's pick the one that's easier, the smaller numbers to work with, the one that doesn't have the halves and the thing in the hundreds. So I know that x plus y equals 18. Well, let's put 12 in for x. So I get 12 plus y equals 18. Subtract 12 from both sides. I'm just going to do it like this. And I get that y equals, that cancels, 6. Right. So that algebraically would find the same solution to that system of equations. Right. So there are 12 adults. That's my x value. And my y value is 6, which represented the number of children. And there we go. It's another example of how to use substitution with a slightly more complicated problem, one where y isn't by itself. Just make it get by itself there.